Okay, we're going to go ahead and do 8.7. Go ahead and try the warm-up. Make sure you put me on pause first and then resume. It says the quotient of 9.2 times 10 to the 6 and 2.3 times 10 squared expressed in scientific notation is. So really what we want to do, we could change it to standard form and work it that way. Or the easier way to do it, if you understand same bases in their rules, would be to divide these two, and 9.2 divided by 2.3 will give you 4. Drop down my times, and now notice that these guys have the same base. So 10 to the 6 divided by 10 squared would be 10, and when you divide same bases, you subtract the exponent. So 6 minus 2 is 4. The decimal point's right here, so that is correctly written in scientific notation, and the final answer is 4 times 10 to the 4th. Choice 4. Okay, these two answers right here, this one is correct as well, however it's not written in scientific notation. So be careful because they're definitely trying to fool you on that. Whoops. Alright, 8.7 is actually a lot easier than the last two sections you guys have done, factoring special cases. These are just more about observation to try to figure out things that you may notice that will help you factor a binomial or trinomial quicker. If you don't understand these cases, it doesn't mean that you're not going to get it right. You still can go through what we've been doing. It says factoring perfect square trinomials. So trinomials means it has 3 terms, like the 2 examples below. Perfect square, if you notice, the first term and the last term are perfect squares. If you notice that, then you should be able to factor this fast, because the square root of this is x and the square root of 9 is 3. Because they're both plus, it would be a plus and a plus. If you FOIL that back out, which I'll do a quick check right here, outers would be 3x, inners would be 3x. If you add those together, they do check back out to 6. So that does check. Now, understand that a lot of times when they leave the answer, especially on a state exam, they won't leave it like that. Because x plus 3 is the same binomial twice, they're going to write it like this, which is the same thing. It's 2 of them. Okay, so let's look at the next one. It's a trinomial, and both of these are perfect squares. So that means take the square root of each. The square root of x squared is x. The square root of 49 is 7. We need same signs to get to a plus, and we have to pick minus minus because of my middle term. They're going to leave my answer as x minus 7 squared. Okay, if you don't notice that these are perfect square trinomials, you still can figure this out. You would just end up listing the factors of 49, 1 and 49, and 7 times 7, and 1 and 9, or yeah, 1 and 9, 3 and 3. So you would just work it out a different method that you've been used to. This is just an observation method. Writing terms as squares to help you factor. You're building a square patio. So let's draw a picture. Anytime they give you a word problem that's talking about some shapes, draw the shape. The area of the patio, and don't forget, if it's a square, which is what they told us, that indicates all sides are equal, is equal to 16m squared minus 72m plus 81. They wanted us to find the length of one side of the patio. So in other words, what times what equals the area. Understand, these two have to be equal because all sides of a square are equal. Let's go ahead and factor the trinomial. Notice that the first term is a perfect square and the last term is a perfect square. If you notice that, then just take the square root of each. The square root of 16m squared is 4m, and the square root of 81 is 9. I need same signs to get to a positive, so because the middle term is a negative, I have to pick the minus minus. Okay? Because these two binomials are the same, That means they're gonna probably write it like this. Oh, I can't circle that. It's a word problem. I have to answer the question. It says, what's the length of only one side? So therefore, one side is, this is the first side, this is the second side. So really it's 4m minus 9 by 4m minus 9. So one side is 4m minus 9. That's what you have to circle because of the question. All right, try these on your own. Guys, go ahead and put me on pause. Take your time, and then put me on resume to find out if you got them right. All right, so in the first one, this is a perfect square trinomial, so you should have ended up with square root of y squared is y, square root of 64 is 8. I need same signs to get a positive, and I'm going to have to pick the minus minus. They will leave the answer as 1 minus 8 squared. Did you guys leave your answer like that? This is correct as well, but just make sure on a multiple choice question, notice this is the same answer. Perfect square trinomial again. The square root of 9q squared is 3q. Square root of 4 is 2. They're both plus, so I need a plus and a plus. How are they going to leave the answer? 3q plus 2 squared. This one, notice it's different. It's not a trinomial, it's a binomial. That's a little bit different. It's still perfect square trinomial, so the square root of p squared is p and p. The square root of 36 is 6 and 6. And because it's minus, you're going to need one of each sign. The question is, if I was to FOIL that back out, and I can't write this answer the way we did on these two because they're different signs, but if I was to FOIL that back out, why does the final answer check back out to a binomial? Because if you multiply your outers, these two, and these two, you're going to get negative 6p plus a positive 6p. And negative 6p plus a positive 6p comes out to 0. So your outers and inners actually cancel each other when you do a check for FOIL. And that's why this is a binomial. The area of a square is this. They want the side of the length just like what we did, so let's go ahead and factor it. Perfect square. Perfect square is 25. We need a plus and a plus. So my answer is 6w plus 5 is the side of the square. Okay? These perfect square trinomials don't happen a lot. So they did in this section because that's where we were introduced to them. But understand that about 10% of the time you'll end up with a perfect square trinomial, which are actually a lot easier than the ones you've been doing in the last couple sections. They just don't come up that much. So be aware of that.